Good day, students. Welcome to part two of the Thea practice test. We're going to be going over questions 11 through 20 on this review installment. All right, in question 11, it says, which of the following is an equation of the line passing through negative 2, 4, and 6, 0? So to do this, we're going to have to write down the equation of a line. So there are two formulas you need to know in order to do this, okay? You're going to need the main equation, which is the point-slope equation of a line. It's given by y minus y1 equals mx minus x1. It's called the point-slope equation because all you need to write this line is this equation is a point, x1, y1, and the slope m. Okay? If you notice, we already have the first point. This is x1. This is y1. But what's missing? We need m. Okay, hence we need another formula, the slope formula, to find the slope, and then we can write down the equation. The slope formula is y over 1 run, so y2 minus y1 over x2 minus x1. Okay, that's the equation for slope. All right, so to write down the equation of this line, first thing we do is find the slope, and then we use a point to write down the equation of the line. All right, so this is x1, y1. So what is this point right here? This point is x2, y2. All right, so this enables us to calculate the slope. So the slope m, let's go ahead and look for that piece first. M is y2 minus y1, 0 minus 4 over x2 minus x1, which is 6 minus negative 2. Okay, if you work it out, you have negative 4 over negative 6 minus 2. You multiply the signs, slash and dash, becomes 6 plus 2 over 8. Okay, this reduces to negative 1/2 if you divide the top and bottom by 4. So divide by 4, divide by 4. That is the greatest common factor of these two numbers. So that's how I get negative 1/2. Okay, now we're going to make use of the first point and the slope to write down the equation of the line. Okay, so we're going to go y minus y1. y1 is 4 equals the slope m, negative 1/2 times x minus x1. x1 is negative 2. Okay, now this is the point slope form of the equation of the line, but we're expected to express it in slope intercept form. Okay, so what is slope intercept form? Is the form you have when you have y isolated. So what we're going to do here is simplify this and get y isolated, okay? So first step is to distribute negative 1/2 to the x and this term right here, okay? So let's go ahead and do that. So we have y minus 4 equals, now you notice if you have two minuses, that becomes a plus, right? So minus times a plus will make that a minus. So negative 1/2 x, negative, so forget that, negative 1/2 x. Now this is a plus 2, right? Because minus times a minus makes it a plus. Negative 1/2 times positive 2 is negative 1/2 times 2. Okay, you can put it as 2 over 1. Remember, whenever you're multiplying, the signs are different, you always end up with a negative, okay? So you have y minus 4 equals 1/2 x, and that is 2's divide out minus 1, okay? So to finish this off, all we'll do is we are going to add 4 to both sides of the equation. Let me copy it back up here. y minus 4 equals 1/2 x minus 1. You add 4 to both sides of the equation, and then your final answer is going to be y equals 1/2 x plus 3. All right, so our answer, negative. I keep leaving out the negative. Negative, or else I'll get the wrong one. Negative, negative, negative. So negative 1/2 x plus 3. Answer is option letter B. All right, so there you have it. All right, let's take a look at number 12. It says, use the graph below to answer the question that follows. So the question says, the graph shows the width, how the width W depends on the length L for a rectangle of constant area. What is the value of W for L equals 8? Okay, so you notice we're going to be extrapolating here. We're going to be making an assumption. So what we have to do is we have to extend this to 8. Okay, that's what I'm saying. We're going to be extrapolating here. So this is 6. Imagine this is 7, and this is 8. So the question is, if I trace 8 to this curve, what output am I going to hit? So we have to extend this curve. You see the path that this curve is following. You notice it's exhibiting some kind of asymptotic behavior over here as though it's approaching the valley. So it's getting almost horizontal, something like that. Okay? So I'm extending this curve to the point of 8 to see where it goes out. Okay? So that's a little bit too straight. Let me do it again. So it's going to look something like this going down. Following that line, it kind of goes down slowly, like that. Okay. All right, so let's see the curve is going down like that. All right, so now what I'm going to do is trace this line to this curve and see what the output is, okay? So if I trace this line, this 8 to the curve, let's trace it up, and then we'll trace it out. Anyway, it's going to reside somewhere between 2 and somewhere between 2 and 1, somewhere between 1 and 2, okay? So let's look at the options that we have that will determine what our output is when L equals 8. So is it 1? I don't think it's going quick enough to hit 1. So let's leave that alone first. 3 over 2 is a mixed form of 1.5. That looks much better. Could it be 4? 4 is way up here. That's wrong. 4 is for 3, so it can't be 4. 96 is off the chart. Take that out. So which one is a better option? 1 or 1.5? 1.5. 1.5 looks like an excellent choice because you notice how it's curving slowly. So it's roughly around there. 1 is way too low. Can be maybe around 15 or something like that. So our answer here is option number letter B. Okay. All right. Let's take a look at the next one. Problem 13 says if negative 1/3 x plus 7 is equal to 16, what is the value of 2x plus 1? So in this problem, we're not just simply solving an equation, we are using the solution of the linear equation to find the value of an expression. Okay, so first thing I'm going to do is first of all solve this for x and then plug in the value of x in here. Okay, so part 1, we want to solve for x. Solve for x. We're solving this equation, negative 1/3 x plus 7 equals 16. Okay, so the first thing we do is we can subtract 7 from both sides. Subtract 7, that yields negative 1/3 x equals negative, actually it's positive 9. All right, and then to get rid of this negative 1/3, what you do is you multiply by the negative reciprocal of this, okay? So multiply by negative 3 over 1 on both sides. Now the reason why we're multiplying by negative is because there's a negative here, and whenever you multiply two numbers with the same sign, you always end up with positive, okay? So because of this minus, we have to use a minus, and since this is 1/3, we use this reciprocal because the multiplicative identities. All right, so these two cancel, divide out, and then minus times a minus is a plus, slash and dash, and then you have x equals negative 9 times negative 3 is negative 27. Okay, so there goes the value of x. Are we done? Is our answer option B? Absolutely not. We just did part 1. It's a two-part problem. So second part we have to evaluate the expression 2x plus 1 for x equals negative 27. Okay, so we're going to go 2 times the answer we got, negative 27 plus 1. All right, 2 times negative 27 is negative 54 plus 1. Final answer is negative 53. So our answer is option letter C. Okay, so there you have it. Okay, let's move on to question 14. This one we are solving an equation for a variable. Okay, using the properties of equality. So we have 5r is equal to 9t plus 7. The task is to look for t. First thing we'll do is subtract 7 from both sides. Alright, and then we'll subtract 7 from both sides. We'll have 5r minus 7 equals 9. Okay, 9t. And then to isolate t, we're going to divide both sides by 9. Okay, Notice you have to divide the entire expression by 9, not just this component right here. Okay, so when you divide it, you have t equals 5r minus 7 over 9. All right, so my answer is option letter A. All right, let's take a look at question 15. It says, what is the solution to the system of equations x squared minus x plus 6 equals y and 2x plus 2y equals 36? Okay, so we can solve this equation by substitution. X squared minus x plus 6 equals y, and 2x plus 2y equals 36. All right, so what we'll do here, if you want to solve this by substitution, you can label them 1 and 2. I have to use substitution here because it's much easier to isolate one variable and plug it into the other. You could use elimination to eliminate the y's, but it's safer to do this by substitution. So substitution is you isolate a variable from a simpler equation and you substitute the value of that variable into the more complex equation. Okay? The simple equation is this linear equation right here of degree 1. I can isolate x or y and then substitute it into the variable up here. If I make a substitution for x, I will have a much longer or complicated problem because I'll have to square my expression and then distribute this minus and then work it out. It will be correct, but it's much longer. On the other hand, notice that y stands alone here, so that's an easy variable for substitution. So I will isolate y from this and take that value from the second equation and plug it into the first, okay? So from 2, we have 2x plus 2y equals 36. We want to isolate y and plug that value into the first one, okay? I want to solve for y. So you subtract 2x from both sides. Let's go ahead and do that. Subtract 2x, subtract 2x. And then that yields 2y equals 36 minus 2x. And then finally, to isolate y, you divide both sides by 2, or divide every single term by 2. And then you have y equals 18 minus x, okay? So what are we going to do now? What we're going to do now is we're going to substitute 18 minus x for y in the first equation. Okay, we'll make that substitution. We're going to have x squared minus x plus 6 equals, instead of y, I'm going to put in 18 minus x, okay? Because that's what the value of y is from the second equation. All right, so let's go ahead and solve this quadratic equation for x. So notice that we can add x to both sides. Let's add x. And what happens is that the x's add up to 0. So you have x squared plus 6 equals 18. So let's get x squared by itself and then we can root it, okay? So subtract 6 from both sides. And then we'll have x squared is equal to 12. And then to finish this off, we'll just take the square root of the left side and the right side. And then you have x equals plus or minus the square root of 12. Now let's go ahead and simplify that. What is the reduced form of square root of 12? If we take a look at our options, you notice that we don't have any square root of 12 as an option, okay? So let's go ahead and simplify that. Let's see. Root 12, break it down using factor trees, take out only primes. 2 goes into 12 because it's even, you're left with 6. Take out 2 from 6 again because it's even, you're left with 3. Now these two numbers, when you take the square root of 2 times 2, the answer is 2, okay? Any factor that repeats itself, when you root it, you'll have just one copy of that factor. That's what square root is. This series stands alone, so you leave it, okay? So the square root of 12 is simply 2 root 3. So that tells me that my solution x equals plus or minus 2 root 3. So x could be negative root 3 or positive 2 root 3. So we don't have to find out what the value of y is. So we just have to just go to the problem and see which one has plus or minus 2 root 3 as the x-coordinate of the solution. And we can clearly see that that option B is the correct answer choice here. That's the one that has positive 2 root 3 and a negative 2 root 3 as the coordinates for x in the intersection of the solution set. All right, so there you have it. All right, so let's take a look at 16. It says, which of the following graphs show the solution of y plus 2x plus 2 equals 0 and y equals x squared minus 9? Now, one thing you can do is, if you take a look at this parabola right here, the coefficient of the square is positive, so we know that the parabola is going to be happy or it's going to open upwards, okay? If you take a look at these options, everything looks good except this one. D is wrong because for this, in this case, the coefficient of x squared should be negative, but it's positive, so this cannot be an answer. Now, let's take a look at this line. Y equals, it's not y equals, y plus 2x plus 2. If we graph this, that should tell us what the answer is, okay? Now, how do we graph this? Well, we need to know the slope and the y-intercept. How do we even know the slope and the y-intercept? We need to get y isolated, okay? So to do that, we'll subtract 2x and 2 from both sides, so we have y isolated. And then that yields y equals negative 2x minus 2. What does this tell me? It tells me that the slope m is the coefficient of x, negative 2 over 1. Okay, and your y-intercept, we begin on the y, is negative 2. All right, how do I know that? Remember the equation y equals mx plus b. The coefficient of x is your slope, and then b is your y-intercept. So which of these lines intersect at negative 2 on the y-axis? That's the question. So this one intercepts at negative 2. So this looks good. This one is bad because it intersects at positive 2, so let's scratch that out. And this one also intersects at negative 2 right there. So these two look good. So which one is the correct one? Is either this one or this one. Now the slope is going to be the determining factor. The slope is negative 2 over 1, so you go down 2 and run 1. So which of them is the line that's going downwards? The answer is option C. This has a positive slope, this has a negative slope, so we can see that the answer is option letter C. Okay? So you didn't actually have to graph it. All you needed was the components of the equation of the line, and then that will tell you the answer. All right, let's take a look at question 17. It's just a process of translating a verbal mathematical expression into an equation form. So let's see how we can translate this from word form into an equation form. So it says C is 10 more than the square of the quotient of the sum of x and y and the product of x and y. So we know the following that the case is basically is equal sign. Okay, whenever C is equal, the word quotient is division. Okay, divide. When you have a quotient, means to divide. And then the rest we know, square is raised to the second power, sum is to add, product is to multiply. Okay, so it says C is this piece of the equation. You write it as you see it. Okay, but that's not always the case. C is, so C equals. Now, whenever you're dealing with more or less, the number that comes before the more or the less goes last. Okay, so we are gonna do this last. It says 10 more. More is to add, right? So 10 more than what? 10 more than this process right here. So you have the square of a quotient and the square of a quotient of two things. Okay, so we're going to do the square first. Before we do this more piece, we're going to do the square first. So we have something that we're squaring. Okay, so what are we squaring? We're squaring the quotient. So we're squaring two things divided by each other. So let's put parenthesis square. We're squaring the quotient. The quotient means the division of what? The first thing that comes after the quotient is the numerator. Okay, so x and y, the sum of x and y. Sum means to add, so the sum of x and y goes on the top, x plus y. And then the number, the variable, the expression that comes next is the denominator. Okay, The quotient of the sum of x and y and the product is to multiply, right? Product of x and y is simply xy. Okay, so you're summing these two right here, and then you're taking the product of these two, and you're going to take the quotient of the sum and the product. So this is the quotient right here, but the instruction was you have to square it first before you do the quotient. So we have this quantity squared, and then 10 more simply means you add 10 after you evaluate this expression. Okay, so if you have more or less, that's the last thing you do it in the grouping structure. Everything else just follow the order. Okay, so the answer is going to be option letter B. So there you have it. All right, let's take a look at question 18. It says the number p is less than the square of the difference of m squared and n. Which of the following equations express this relationship? So you remember earlier when I said if you have more or less, that's what comes last, okay? So p equals 50 less than an expression. So let's leave this 50 alone. We'll do that last, but let's figure out what the expression is first, and then we subtract 50 afterwards, okay? So we're squaring something. So let's square, put parentheses square. What is the argument of our square? It's the difference of two things. What are the two things? The difference of m squared and n squared. So in the parentheses, we have m squared minus, remember difference is minus, right? The difference of m squared and n. So this term we have here is the square of the difference of m squared and n. Okay, is that all you're doing? Nope. Less 50. So this less 50. So you take 50 out of it. So there you have the expression. So we can see that our answer here is option A. Okay. All right, let's take a look at question 19. Question 19 says, a 10-foot long board is cut into 3 pieces. The second piece is half as long as the first. The third piece is 4.5 feet longer than the second. How long is the first piece? Okay? All right, so let's go ahead and do this. So if you notice here, the second is described in terms of the first, and the third is described in terms of the second. All right, so since everything is directly or indirectly dependent on the first, let's use a variable to declare our to be assigned to our first variable. Okay, so I'm going to declare my first variable using x. So let x be what? Length of first piece. Okay. All right, so x is the length of the first piece. So if x is the length of the first piece, then the second piece is half as long. Okay. So um, length of second piece, length of second piece is going to be what? Half as long. What does half as long mean? If it's 20 feet, for example, if the first piece were 20 feet, the second piece would be 10. How do you do it? You divide by 2. That's what half as long means, right? So the first piece is x. Length of the second piece is going to be x divided by 2. Okay? All right. And then what is the length of the third piece going to be? The length of the third piece is 4.5 feet longer than the second. So this is an additive relationship. If it's longer, it means you're adding, okay? So basically what you're going to do here is you're going to take the second piece and you're going to add what? The additional length, 4.5, 4.5, okay? Like that. So these are the lengths. First piece, second piece, which is half as long as the first, x over 2. And then the third piece, which is 4.5 feet longer than the second, so the second plus 4.5 feet, okay? So this gives you all the lengths. All right, so what can we do with these terms right here? Let me give you a visual. So we have um, a piece of, what was this piece of what? A board. Okay, so this is your board right here. So this, let's say the first piece was x right here. And then the second piece is x over 2. And the third piece is x over 2 plus 4.5. Now, what can I say about this? How can I formulate an equation? Wait a minute, we were told that um, the entire board is how long? It's 10 feet, right? So the distance from here to here, the entire length is 10 feet, okay? Right, so it's 10 feet long for the length of the entire board. So the entire board is 10 feet. So how can we form an equation here? Well, we just know that the sum of the individual pieces is equal to the entire length, right? So our equation is going to be x first plus second, x over 2 plus third, which is x over 2 plus 4.5, equals 10. Okay, we solve this equation for x. That would be the length of our first piece. If we divide that answer by 2, that would be the second. If we divide the answer we got, the second answer, if we add 4.5 to that, that would be the length of the third one, okay? So all we just have to do is simply solve this equation for x, and what we asked to find, the first piece. So when we find x, that should be our final answer, okay? All right, so let's see. How do we solve this? This 4.5 right here, it's not a variable, so how about we move it? Let's express it as an improper fraction first, and then we'll move it to the right side, okay? All right, so what is 4.5 as an improper fraction? You basically multiply the bottom, the denominator with a number, and add it to the numerator, right? So 4 times 2 is 8, plus 1 is 9 over 2. All right, so we have x plus x over 2 plus x over 2 plus 9 over 2 equals 10. All right, now let's see what we can do here. We can combine these two, x over 2 and x over 2. That's going to give us 2x over 2. And this number was a problem before because it's not a variable, so we wanted to move it to the right, right? So we subtract 9 over 2 from both sides of the equation, all right? So that equals 10 minus 9 over 2. Okay, let's simplify this further. X, this is nice because 2x over 2 reduces just to x, right? So we have x plus x equals 10 minus 9 over 2. We can write it as 10 over 1. Now, how do we subtract 9 over 2 from 10? We find the LCD. To do that, you multiply top and bottom by 2. And then this becomes 20 over 2 minus 9 over 2. Okay? So we have 2x. X plus x is 2x. And then when you combine these two, 20 minus 9 is 11 over 2. All right? Okay, now to finish this off, we divide both sides by 2, but this is a mess because we have a fraction here. So alternatively, I can multiply by 1/2. That's the same thing as dividing by 2. Okay? When I do that, I'll have this 2's divide out, and I'll have x equals 11 over 4. And in mixed numbers, 4 goes into 11 twice. That's 8, remainder 3. So 3 over 4 feet. So this is how long the first piece is. So we can clearly see that our answer is option letter C. Okay? All right, let's take a look at the last one. Question 20. It says, Angel has $1.80 nickels, dimes, and quarters in his pocket. He has twice as many quarters as nickels. The number of dimes in his pocket is one more than the number of nickels and the quarters put together. Which set of equations could be used to determine how many nickels, dimes, and quarters Angel has? Okay, so we know that dimes are dimes are 5 cents. No, actually, dimes are 10 cents, right? Dimes are 10 cents. Nickels are 5. That's when that's 5. Nickels are 5 cents, and then quarters are 25. Okay. All right, so when we're working with this problem, it's easy to work with cents, so we don't have to deal with decimals, okay? So if we want to call n equals number of nickels and d equal number of dimes, I'm using these variables because that's what the alternatives are in terms of, okay? The denomination, the variables in the alternatives are n, d, and q, so that's what I want to stick with. And then q is number of quarters. All right, so to do this, first of all, we know that the total amount is $1.80, which is 180 cents. Okay, we're dealing with cents. So we're going to have um, the number of, the amount of quarters is the number times the denomination. Okay, because you know total is price times quantity, right? So whatever the total is going to be the price times the quantity. So if we want to deal with total number of nickels, is going to be the number of nickels we have, which is n, times the price. How much is the value of each nickel? Is 5. So it's going to be 5n plus. You want to deal with the total price, total the value of the all the dimes you have. You do the price times the quantity. How many was what is the value of a dime? Is 10 cents. And then how many dimes do you have? You have d dimes. Okay. And then we have nickels taken care of, dimes, now quarters. Total value of the quarters you have of that Angel has in his pocket, the value is 25 cents for each one, multiplied by the total number of quarters you have. How many quarters does he have? He has Q quarters. If you add all of this together, you have the total number of the total value of coins he has in his pocket in cents. Remember, we're dealing with cents here, so it's going to be equal to 180. All right, so let's see which options we can eliminate from that. This one looks good. 5n plus 10d plus 25q equals 180. Good. This one, 5n, 10d, 25q. Good. This is bad because you have a decimal here. This is wrong. And then this is inconsistent because you're dealing with dollars here. That's why these are in decimals. And then here you're dealing with cents. So you have inconsistency with denominations. So this is inaccurate. Okay. If you're dealing with cents, make the entire equation cents. If you're dealing with dollars, make the entire equation dollars. You can have dollars and cents. Had it been this one is equal to 1.8, that'll make it correct, but that's not the case, so that's why it's wrong. All right, so first equation set. Now let's look at the second equation. That might help us determine what the correct answer is, because this is q equals 2n and this is n equals 2q. So let's go back to the question. It says the number of dimes in his pocket. Now let's go to the second statement. It says he has twice as many quarters as nickels. So which is more, the quarters or the nickels? He has twice as many quarters. So we have more quarters than nickels. Okay? So what that tells me is that the number of quarters you have is twice the number of nickels you have. How many nickels do we have? N, right? So it's twice n. So Q is equal to 2n. And that tells us that option A is correct. Okay, this tells us that you have twice as many nickels as there are quarters, which is not the case. All right, but you have twice as many quarters as there are nickels. That's why you have Q equals 2n. So if you get confused about it, you can use some numbers. For example, if you have 5 nickels, for example, 5 with 5 nickels, how many quarters are you going to have? Twice as many. So you're just going to double the number of nickels 2 times 5, which is 10. Okay, so that's basically how it works. You have more quarters than nickels. That's why you're going to be doubling the one that's smaller. All right, so we can see that our answer is option letter A. So that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here and post a comment to let me know what you think about this presentation. More clips can be found on mathgotserved.com. Thanks again and have a wonderful day.